Good morning. Welcome to another session on environmental impact assessment.
So we shall continue with Unit 2, Methodologies. Course outcome, elucidate the methods of EAA with case studies. Learning outcome, discuss the methods used in EAA. Specific outcomes, list of the methods used in EAA and explanation of the ad hoc method. So in the last lecture we have seen uh, all the methods in brief, meaning I have explained in brief each of the method that can be used for EAA analysis, right? So we shall continue from wherever we left in this lecture. So we have so many methods as we have seen in the last session, right? If you have just to recollect what are those methods, we have got um, ad hoc method, checklist method, we have got network method, we have got matrix method, we have got overlay method, we have got environmental index method, cost benefit analysis method, and simulation modeling and workshop method, right? I have not spoken about the last one so much. Why? Because that is not there in your syllabus. But what actually that means is like you are going to do some modeling. Yeah, I think I shared something about that. So you'll be doing some modeling and try to predict what will happen in the future, right? So that is what the simulation modeling method is. But here you can notice in this table uh, that ad hoc method has been removed because ad hoc method is very crude method, and actually it is really not good to use that method when compared to so many other methods we have. That is the least adopted method, right? So they are not given any parameters, or they are not evaluated the parameters for that particular method in this table. So let's look at the criteria. So these are some of the criteria based on which these methods have been evaluated, right? So number one is comprehensiveness. Comprehensiveness actually means that you are it takes into account of all the features. Comprehensive means it is in toto. That is the meaning of comprehensiveness, meaning none of the factors have been left out, right? We are seeing everything as a whole. You might have heard of this term holistic approach. Holistic approach meaning holistic approach and individualistic approach. So when you say holistic approach, you are seeing everything as a whole, right? mm, we to give an example of this. um, for example, assuming you are assessing a student, right? So you just don't assess him only based on his performance in the exams. You assess him based on his behavior, you assess him based on his involvement in co-curricular activities, extracurricular activities, his ability to take responsibilities, right? Maybe he is some member of some committees and so on, like, so you are seeing him as incomprehensive. That is the meaning of comprehensiveness, right? So communicability, whether the method will be able to communicate its results to the people. Flexibility, how much flexibility is there? Flexibility, I think you know what flexibility is, right? How flexible the person is. So something like that, flexibility. Objectivity, so there are two things here also. When you there are two things, one is subjectivity and another is objectivity, right? So when you say subjectivity, we are saying at that particular instance how, taking the same example, how that student is behaving or something like that. When you say objectively, as a whole, how he is, right? So that is the difference between objectivity and subjectivity. So here again, objectivity is something like similar to comprehensiveness, but a little more refined, in the sense like we are seeing everything as in as a whole picture. Aggregation meaning whether the method is capable of putting everything together, summing up all the parameters, summing up all the data. Replicability, whether the results can be replicated, right? Multifunction, whether it is capable of taking into account of you know different functions, or is it focused only on one particular function? Uncertainty, whether it takes into account of uncertainty. So here you can see that in uncertainty, that most of the methods do not take into account of uncertainty. Why? Because they don't know what the future impacts will be. So that is n is negligibly fulfilled. You can see that uncertainty is negligibly fulfilled in all of these or most of them, except one, that is simulation modeling. Why? Because you'll be trying to simulate some scenarios and trying to find out if this happens like this, what will be the impact, if this happens like that, what will be the impact. So only in that case you can have the uncertainty component. In all of the other methods you cannot have the uncertainty part. Space dimension, whether it takes into account of the area, how much locality, or meaning in terms of space. So whether it accounts for all the locality, or whether all the surroundings will be taken into account, whether that methods consider that particular uh, principle or component. That is what the space dimension is. Time dimension is whether it is accounting for the time aspect, how the impact will change with respect to time, whether that component has been incorporated in that particular method. That is a time dimension. Data requirement, how much data is required, whether it takes into account of the data requirement. Summary format, right, whether it is summarizing the all those impacts, whether alternative comparison has been conducted, or alternative comparison is possible in that particular method, right, meaning we cannot go for this particular process. So is there any way to compare different processes or different alternatives for that particular project in this particular method? Time requirement, right? So time requirement is it's not same as time dimension, right? So time requirement is how much time is required, whether the method consider this aspect of taking into account of how much time will be required to conduct the EIA. Manpower requirement, whether the process takes into account of how much manpower will be required. Economy, right, economical, that is the aspect, whether that is taken into account by this particular method. So these are some parameters based on which the methods have been evaluated, right? So L here refers to completely fulfilled, S refers to partially fulfilled, N refers to negligibly fulfilled, right? So L is low source need because it is fulfilled, so you don't require that much sources. S is partially fulfilled, so moderate resources are required. N is negligibly fulfilled, so you need lot of resources. So let us look at one by one. So when you see the checklist method, right, I told you what checklist method is. The reason why I explained everything in brief is because you should know what that particular method is, right? So that's the reason why I gave a brief description in the last session, so that you know what I'm speaking about, right? So in the checklist method, we are just making a checklist and trying to see whether that has been covered or not. So you can see that there are about 5 ends, that is negligible fulfilled components are 5, right? And completely fulfilled is uh, about 7, right? When you come to overlay method, you see the number of ends here again 5 ends, but the number of L's are only 4, right? When you go to the network method, you will see again about 4 ends, but the number of L's are about 4, right? About 4 L's. Matrix method, the number of N's is 4, the number of L is about 1, 2, 3, 6 L's, right? So environmental index method, you got only 1 N and you got only 3 L's. Next one, you got about 2 N's and you got about 5 L's. The last one, you got about 5 N's and you got about L's, right? So this is some crude way of seeing which one is better than the other one, but this is just one way of looking at it. But it is not based on this that we decide which method is the best, right? We know the characteristics of each method, we know the advantages, we know the disadvantages of each method. So if you see in that way, you will see that the checklist method is best because it has got 7 L's, right? But the checklist method is actually you just making a checklist of all the parameters, checklist of all the impacts, and then seeing whether it is covered or not covered. So that is actually not so good when compared to you have network method and matrix method, where you will be making where you will be trying to find out the relationship between the parameters, relationship between the impacts, and whether you have only what do you say, primary impacts, or we have got something called secondary impacts, tertiary impacts, meaning how the impact is progressing, right? uh, for example, you got some impact on maybe water bodies. This will again lead to secondary impacts, meaning the aquatic animals will get affected, and then this affect aquatic animals may be consumed by human beings, and that will lead to the death of some people, or maybe getting some diseases. So that is a tertiary impact. So like that you can see, in case of network method, you can see the various relationship between the various impacts. So this table is just to give you some idea about um, the various parameters that can be evaluated for a particular method, but we cannot say that based on this we cannot say that this method is the best method, right? So it depends on the project which you are going to evaluate in terms of the EAA, right? That you will have to choose the method. You cannot go by the generalized uh, the number of n's and number of l's. We cannot decide this method is the best for all the projects. We cannot take such a view, right? So it depends on the project, depends on the parameters involved, and then you'll have to look at the pros and cons of each method and then choose the best method for your particular analysis. So let's stop this session here. We'll continue with the remaining portion of this presentation in the next session. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.